I am very sorry. I forgot to start the video. Right now, they're on the section called ring structures. And what they did is they built regular hexane, and then they turned it into a ring structure. And now, because this guy has a different formula, instead of C6H14, it's C6H12. You can't call it hexane, but they called it cyclohexane. And now what they're building is probably the most famous ring structure in all of organic chemistry, and it's called benzene. This is a benzene ring. All right, now, please don't change the benzene ring. I know some of you want to be ahead of me, but let's stay with benzene. I want to tell you about this thing. This ring structure is really, really important in organic chemistry. And you'll hear about the benzene ring. Oh, it has 5 benzene rings in it. Now, I want you to take a look, and can everybody look at here for a minute? This is unusual. Here's C6H14, here's C6H12, but what's this one? C6 what? Man, what happened? What happened to all your hydrogens? And this was all single bonds. This was all single bonds, but you made it into a ring structure. That's why you lost 2. But now it looks like you lost 6 more hydrogens. What did you do? How many? This will cost you 2. This will cost you 2, and this. Now let me tell you something that I haven't taught you yet. And some books call it a stick structure. I like to call it the abbreviated structure, but I think your book, does it call it stick structure? So some people call it a stick structure. Let me tell you what organic chemists do, because they don't really want to write this out. They don't want to write, it takes a long time to write that. What if I want to tell you about benzene? And let me show you, this is pretty neat how they do it. It's pretty neat. Watch. They're going to go like this. And they're going to go like this. That's one way to write benzene. Now, here's what an organic chemist does, okay? It says, see these sticks? These sticks are covalent bonds. And it's organic. What's at the end of the stick? It's got to be carbon unless I tell you it's not. It's carbon unless I tell you it's not. So what's at the end of this stick right there? A carbon. What's here? A carbon, carbon, carbon. So I see the 6 carbons in there. You're supposed to be smart enough to know that carbon likes to form 4 bonds. Ready? 1, 2, 3. There must be 1 hydrogen there. How about this carbon? 1, 2, 3. I must have another bond with hydrogen. And so by using the stick structure abbreviated, all organic chemists know what you're talking about. That's benzene. Now, here's another way to write benzene. That is very, very common. Now, let me tell you what they're talking about here. And this is a new thing. You've never heard this in chemistry before. Do you see these double bonds? Double, single, double, single. See that? They have proof that that doesn't stay as a double bond. It'll shift over here. And they'll go, the doubles and triple bonds will shift. They'll go. And it's called a resonance structure. They resonate. So the double bond's not always there. It's over there sometimes. And so they'll draw this like that. Now, if you meet a real organic chemist, here's how you do benzene. See, they don't even want to take the time to write the 6 sides. Now, let's go backwards and write the stick structure for cyclohexane. Aha! See, to an organic chemist, I know what you're talking about. That's C6, and every carbon wants how many bonds? And I already know you have 2 bonds, so there must be 2 hydrogens there. So C6 and 2 and 2 and 2 and 2. And see that? That's what they do. Let's go backwards. How do you do hexane? What? Hexane? Well, I don't know. Can you do that? Watch. Hexane. 1 carbon, 2 carbons, 3 carbons, 4, 5, 6. That is hexane. To an organic chemist, that is hexane. One more time. What's found at the end of a stick? Carbon. And unless I tell you it's not. And carbon likes how many bonds? 4. There's 1. He must have 3. Here's 2 bonds. You must have 2 hydrogens. And this is called an abbreviated or stick structure. And so benzene, cyclohexane, hexane. All right, let's try another one. I want you to make a stick structure for propane. Let's go back to, let's go back. Let's do propane. What's the stick structure for propane? Let's go back over here. Let's go down to alkanes. Here we go. Let's make a stick structure. By the way, I've never seen a stick structure for methane. I don't think they do a dot. No. Ethane. Here's ethane. Ready? There's ethane. How about propane? Now again, wait, you can't do this. I know what you're thinking. You're going to go, No, you don't do 2 straight lines. No. See that? What's that called? How many carbons in this thing? Oh, there you are. 3 carbons, and the rest must be hydrogen. If they're not hydrogen, I have to let you know. Let's do butane. 1, 2. This is kind of fun. Now, let's do propene. Let's do propene. Propene. Stick structure. Propene. That'd be propane. How do I do propene? There you go. There you go. And again, watch now. At the end of every stick's a carbon. Here's carbon. You only have 1 bond, so I bet you have 3 hydrogens here. Here's a carbon. If you already have 3 bonds, there's only 1 hydrogen here. And here's a carbon. You have 2 bonds, you'll have 2. That's how they do it. Now, let's try another one. Ready? Ethanol. Let's do a stick structure for ethanol. 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 Ready? Ready? Ethanol. Where's ethanol? Here it is. Ethanol. Remember, I have to tell you, if it's not a hydrogen, then I have to tell you, don't I? So I know there's a carbon here, and he must have 3 hydrogens on him. And I have a carbon here, but he has this bond plus this one, so he must have 2 other hydrogens, right? And that's the way they would do that. Now let's do propanol. Let's do the stick structures for propanol. How about propanol? All right, let's see if you got it right. Ready? Propanol has 3 carbons. There's my 3 carbons. Everybody got that? 1, 2, 3. Propanol. Now, here's one of the propanols, but there were 2. If you did 2, pat yourself on the back. Thank you. And the other propanol was this one, wasn't it? What do you think? You like that abbreviated? You like the stick structure thing? Pretty neat. Pretty neat how they did that. Now, okay. The reason I wanted to show this to you is that I don't know if you ever got medicines or your parents have medicines, but they put this incredibly tiny writing. They act like they're doing, I gotta give you the instructions here, but nobody can read that little stuff. But many times you'll get a medicine and they'll have a picture that might look like this. Now, most people, I would say out of 500 people, maybe 3 might know what you're talking about if you showed them something like this. Like if I were to show you this picture here, would you be able to figure out, and we'll do this on another day, would you be able to figure out the formula of this guy? If I said well, let's do it now. If I said to figure out the formula on this, would you be able to do it? Okay, now let's try it. Ready? At the end of every stick is a what? So let's go ahead and write those in there. And what about right here? Is there one here? Is there one right here? Yes. How about right here? Okay. How about here? Yes? Okay, I think I got the carbons. What do you think? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I got that down. I bet I have the oxygens too, don't I? How many oxygens? 1. Okay, so that's done. Now, hydrogens are tricky. How many hydrogens is this guy going to have? Careful. He has 1, 2, 3. He already has 3 bonds. So how many? 1. This guy has 3 bonds. This guy has what? Okay. And what about this carbon? Yeah, 3 bonds. Okay. Ooh. 1, 2. Oh, wait. 1, 2, 3, 4. What's that mean? No more. 1, 2, 3. 1, 2, 3. 1, 2, 3, 4. I think I'm done. All right, let's count the hydrogens. Ready? 1, 2, 3, 4, 5, 6, 7. So I would say most people, when they see one of these structures, whether it's on a medicine package or somewhere else, did I miscount? 1, 2, 3, 4. Oh, right here. My fault. My fault. Sorry. My fault. 1, 2, 3, 4, 5, 6, 7, 8. Sorry. All right. Most people have no idea when they see this what that means. And so, you see the benzene ring here? There are so many medicines that are made with benzene rings. So we're going to go back to benzene, okay? All right, ready? Let's go to benzene. And what I would like you to do is I would like you to replace one of the hydrogens with an OH. You guys are good. You're good. You're very good. They're way ahead. They knew that's what I was going to ask next. So that's why you guys are so smart. You're so smart. Okay, there you go. All right. Everybody got it? Now, you can't call this benzene anymore. And so one of the names, and I can't change some of the old names. Like even benzene. Why didn't you call it like cyclohexatriene? That would be a good name. Cyclohexatriene. 3 double bonds. I think that'd be a good name. But if you want to read about a person, his name was Kekulé, not Hercules, Kekulé. And he supposedly worked on this year after year. He couldn't figure out what the structure of benzene was. That's before they knew all the stuff we know now. And he had a dream once. And he couldn't figure out how these things could be bonded together. He had a dream one night about a snake. And the snake went around and it started eating its own tail. And he woke up. He said, that's it. That's it. They must form a ring with each other. And if you want to find that story, I don't know how much is true or not, but his name is Frederick Kekulé, maybe. And he's one of the people that discovered benzene. Now, this is not benzene, but this is one. It's called phenol. Now, phenol is, you put an OH group here instead of an H. And have you ever heard of phenolphthalein? Okay. There are some pollutants in the air. Some of them are called biphenyls. Anyway, when you hear that, it's a benzene ring with an OH group on it. Now, let's make another one. Let's see if anybody's ahead of me. I want to do, instead of having an OH on top of it, I'd like to have a CH3 group. Yeah, that's good. That's good. That's very fast. Of course, they beat you. All right, what do you think? All right. That's it. Now, we have to give it another name. And here's the stick structure, by the way. Here's the stick structure of that. Hey, everybody look out here. Notice that it's just a stick. You're supposed to know what's at the end of that stick. A carbon and 3 hydrogens, right? Now, this one's called toluene. Toluene. Now, I didn't know it when I was growing up. But when I like to build models back then, and kids like to build model cars, and I'd build cars, and I'd build model kits. I did a ship. I remember doing a helicopter. I did all kinds of models. I don't know. I just enjoyed models, and then if I really got into it, I paint the models, and it was pretty neat. Now, they stopped selling that glue because in the 60s, a lot of things happened in the 60s, okay? In the 60s, as people got more free to do different things, they figured out that you could take airplane glue and put it into a brown paper bag and just breathe into it like that, and you would get high. Now, what they didn't know, and of course one person tells another person, what they didn't know is as you do it more and more, you could kill yourself. Some people died, and so they had to essentially get rid of my favorite airplane glue. Now, I remember building those models, and I remember every time I was building, it has a very distinctive smell to it. It's called toluene. They used to use toluene until a few years ago. Everybody who had fingernail polish remover was toluene. And that worked really well to get rid of the fingernail polish, but you know what happened? People started, okay. So now I'm not sure what fingernail polish remover is now, but they had to get rid of the toluene. All right, so if you were to look this up in another book, toluene also has another name, methyl, get it? Methylbenzene. Okay, and here's my favorite. Some of you are ahead of me. We're going to make toluene, but we're going to put 3 nitro groups on it. We're going to make tri-nitrotoluene. I will tell you that the benzene ring is incredibly stable, and you seem to be able to attach many things to it. You can even have a benzene ring attached to another ring and another ring and another ring. So they're kind of stable, and then you can have all these other things sticking off of it, and you've got this compound, this one. So when companies try to make their own compounds, synthesizer, right? They'll try to put benzene rings together, or benzene with a pentane, maybe a pentane ring. And but nature, God already knows how to make an incredible number of these things. Okay, there you go. Now, I wouldn't attach the end to end. I wouldn't attach the ends to ends. Now, I just watched. I know that you guys. I know every Wednesday night at 9 o'clock, you guys watch public television like I do. Now, it's not like I watch that much television anyway, but every week on Wednesday at 9 o'clock on public television, they have a science show called Nova. How many of you have ever in your life watched Nova? Okay, thank you. At least one person has. There are some days when the shows are about warfare, how they make jet engines, okay? The science of jet engines. They had some the other day about rockets. The whole show was about rockets and the history of rockets. But last night, I have to tell you, hey, everybody stop for a minute. Everybody stop. Stop building. They had one called Chemical Reactions. And I thought it was really good. And if I can buy it, I might do it. But they went through a whole series of chemical reactions, and some of them were this one, like explosives, okay? And I haven't taught this to you yet, but I would have taught this to you, that what is it makes TNT so explosive, right? And what happens is, this, and they did it even better than I used to teach, so I'm going to start teaching a little differently. Right around you, about almost 79 or 80% of what you breathe is what they call N2. Now, N likes to form 3 covalent bonds, and so is the other N. And so this stuff that is going in and out of your lungs is called N2. Well, nitrogen is very important, but you know what? It's incredibly hard to break that triple bond. And so the nitrogen goes in your lungs and comes out. It doesn't do anything. It's kind of inert. But everybody needs nitrogen, and every plant needs nitrogen. You need nitrogen, but you can't get it. You live in an ocean of nitrogen. You can't touch it. So we have to get it from other sources. Proteins have nitrogen. But how does a plant get it? Okay, so what happened is, for some plants, in their roots, they have little bacteria that are called nitrogen-fixing bacteria. And without any factory or anything, they take nitrogen from the air and turn it into nitrate groups. Or they might turn it into ammonia. Now, both of those are soluble in water, and they can be taken up, and a plant can get its nitrogen that way. Humans figured out how to make this, but it was costly. And they talked about that program. It's called the Haber process. And what he did was he learned how to take nitrogen gas, and what he would do is he mix it with hydrogen gas. They don't really want to mix. This guy's very inert. He doesn't really want to do anything. But then they figured out, that's why the guy got so famous. If you take hot iron, and if you heat it up really hot and run the gases over it, it acts as a catalyst, and it'll join them together and make this thing here. Now, there was a problem. There was a problem with that, and you learned this on another chapter. This happens, but guess what else happens? The reverse reaction happens. So the key is, how can I get this reaction to take place and not go reverse very much? And that's what made him so famous. Now, this German scientist named Haber, I said Haber, they say Haber, he changed the world in a way. Because once you started to learn how to do this artificially, you could turn these into nitrates or ammonia. And now guess what you can do? You can spread those over the fields, and instead of growing 100 bushels of corn, you can grow 5,000 bushels of corn on the same amount of land. And it literally allowed another 2 billion people to be alive. They said if we were to stop this process today, about 2 billion people would die of starvation. That's how we do. We actually learned how to make fertilizer for plants. Now, bad news. This guy named Haber, he stayed around when Hitler is in charge, and he was a great chemist, and he also made bad chemicals that killed people. So anyway, long story short, let me tell you about nitrogen, okay? If you can get nitrogen in a compound like this one, it's very unstable. It would love to jump back into a real stable compound called N2. So if you were to set this off, if you were to set TNT off, what would happen is this big molecule would turn into a lot of little ones like water and N2 and all the energy that used to be holding that thing together, we don't need it anymore. And so it's released. And what happens is the gases around this explosion will heat up so fast that it'll set up a supersonic wave of air. And that's how you blow things up. So, is it true that even on the internet, you could buy fertilizer, which has nitrogen in it, mix it with gasoline, and make an explosive? That's on the internet. On the other hand, if you buy a lot of fertilizer and you don't live on a farm, the FBI will knock on your door, and they'll figure out who you are. So don't go around trying to buy a bunch of fertilizer unless you live on a farm. Okay, hey, can I tell you something? Wait, listen. Wait. It's pretty close to having time for a little quiz. Not today, but maybe Monday. Okay, I'd like you to study this, read your packet, and might have a quiz on Monday. All right, you did a great job today. The quiz just gonna let you know how much you retain, how much you retaining, okay?